Hello, I'm Koshti Silva, and I'm here today to show you how the TIBCO suite can be put together to go from insight to action in the problem of financial crime. In this case, we have set up the Spotfire template so as to be able to aid the business user in finding the relevant patterns of crime in his historic data. Toward end, we will use the patterns he has found and captured mathematically and deploy them to the real-time engine using easy-to-use dashboard. This template is composed of 4 parts. In part 1, the user can visually play with the data so as to make hypotheses regarding which KPIs are important, which he should keep, and create a strong data set to find financial crime in. In part, we're going to be using supervised algorithms that are a set of mathematical tools that allow distinguishing zeros from ones and therefore understanding what are the patterns of historic data. We're going to characterize transactions to find what is normal transactions and against them identify the odd transactions. And finally, in part 4, we can just deploy all the knowledge we've gathered from our easy-to-use dashboard into real time. So explanations in this template is supported by the white paper we have created and published on the internet. First part, ad hoc data discovery. We invite the user to replace the current data table, fraud input data with his own data, and everything else should work normally from there. So in this page, we can just look at the distribution of any KPIs in the data, just to see if there's some errors or problems with the data that might require, for example, some data cleansing. Part here, we invite the user to use this histogram to select in the x-axis what is the level of granularity at which he wants to look for fraud. So they want to look at by transaction, by client, by branch, for example, by branch. So he can choose that and place it in the x-axis. In the x-axis, he can take any KPIs. So in our case, we're looking at the average number of transactions made from a card per transaction. Over the last 24 hours for each transaction. And we can see that most transactions have really small numbers of transactions done in the last 24 hours using the same card. And you have some transactions that have really unusual behavior. And unusual behavior is what we believe fraud leaves behind in an organization. The type of KPI you want to keep. And all this theory is explained in the instructions on the left-hand pane. If your historic data includes information about which variables are, which lines in your data are fraud and which are not, you use this information to understand other variables in relation to them. So use the variable that contains the fraud flag. Here, the fraud flag is identified. So in our case, we put 1 for fraud lines and 0 otherwise. And when you change the rules here, you can see the behavior of the categorical variables or of the numerical variables in relation to fraud. So all this allows then the user to increase his understanding and his culture about the data and have better second sense to it. This information to the test when we apply mathematical models to them. The importance of these models is that they help solve one of the biggest problems that financial crime handling has these days, which is that organizations are swamped with many false positives. Because often when they find an interesting KPI, they find a rule that applies to each KPI individually. Now, if you use machine learning, which is what we do in this page, you can those thresholds by combining the different rules and into measuring the probability that a transaction is fraud given all you know about it, and of course much more efficient. The user can, if he hasn't before, he can select a variable that contains the fraud flag, what the actual flag is, and what are the KPIs that he's going to use as predictors for the fraud flag. So when you press the button, we call out to TARE, which stands for TIBCO Enterprise Runtime for R, and it's a statistical engine that runs R in a business environment and with business quality. And TARE takes the information we have passed it and applies the random forest algorithm, which specializes in separating those zeros from those ones. So this output, which speaks business language, talks about the predictive ability of each of those predictors. And so it gives us an idea of the strength of KPIs that have been chosen. So, for example, that the number of transactions over the last 24 hours made with the same card device and account are much better predictors than, for example, the value of the transaction when it comes to being able to predict fraud. This page allows you to do model assessment. So it gives you an idea of the quality of the model. So in this line here, gives you, you want it to be as close to the green as possible and as far from the red, and that is a measure of quality of the model. The x-axis will show that if you just by selecting 10% of all existing transactions, you manage to capture close to 100% of fraud. So this, of course, is a very important indicator for someone who is thinking of a financial crime fighting strategy. In this model to a test set, you can see that most transactions receive very low probability of being fraud, but a small select number of transactions that have high probability of being fraud, and historically you can see that they actually were. If you take a threshold of 64% for the probability of being fraud and make sure you investigate all of those, you see that you only have a 21.5% proportion of false positives. So if you then decide to use this threshold, we can inscribe this threshold here in this area, and what is going to be used going forward. Sorry, wrong word. It's for the real-time part that will come to. We can use another type of model, which is called unsupervised model. And they do not need to know a priori which variables, which transactions were fraudulent and which were not. Instead, they look at what makes normal transactions for this company and for this data, and those define and identify the abnormal ones. So let's look a bit more into this. We use a technique called principal component analysis, which is a type of factor analysis. And the user just needs to select what variables he wants to expose to the method, press the button, and TARE applies the analysis and a factor space. 0, 0 represents the normal average transaction, and anything far from this 0, 0 is just more unusual. So measure the distance between a transaction in the factor space and the 0, 0 has a measure of its oddity. So there's some options here in the next page where you can see some different options for measuring oddity. This page is entirely optional, so we will not cover it very much. And finally, you have the results of part 3, which is very much like very similar to the results of part 2 for consistency and for clarity for the user. Basically, that most transactions are quite close to the origin, and then you have a few that are really unusual in terms of delivering the most important factors. And in these, you can see that there's only 16% probability of false positives, meaning that with this selection, 84% of your investigations are actual fraud cases. So to use this threshold going forward, so we store it here, and in part 4 we can apply the models, the bull models, to make an investigation. So we apply it in batch in the sheet if that's the case. So we simply supply current transactions by leaving the fraud flag empty. This is our list of existing transactions with a probability of being fraudulent and the respective oddity. And I can work my way down this list. This slide is served for what if analysis. So, for example, if average it takes me 92 minutes to investigate each operation, and I have 20 people. Below, I can see it's going to take me 14 days to investigate all the transactions that are above the existing threshold. So I may want to go back to review my threshold this morning. Mostly, however, is that now we want to deploy these models in real time to all transactions that are currently happening in the bank, for example. And you can simply press this button and launch the supervised model with the respective threshold, the current threshold, onto Streambase, where Streambase is the real-time aspect of this. The button below and the unsupervised model, so the factors that we've seen with the respective threshold, again, to Streambase and this other information that can be used for treating this example. So now to the real-time side of this. So Streambase, the editor never ever sees this. Importantly, we can see that at the top part we've made a section for loading new models. So this part gets activated every time we switch Streambase on, and the bottom bit gets activated every time Streambase detects that the new model has been saved from Spotfire. And when the models are loaded into TAIR, the TAIR exists natively inside of Streambase. Some part, we're actually going to score any existing transaction as it happens against those two models, or against just one of them if I've just made one. And we're going to separate out the fraudulent transactions, which are those which probability of being fraud or which obviously are above a certain threshold. We're going to publish everything to live view, a real-time dashboard that appears in real time as transactions occur. When we spot an alert to a fraud condition, then we're going to open Spotfire again in Spotfire Automation Services, which is an automated Spotfire response, and to do this and pass in the information about the specific transaction ID, you see it in the yellow part, so as to get all the context of the transaction. So let's resume. I had paused this Streambase, so I've now resumed it, and we start by seeing the time component where my transactions are happening, and real time I'm seeing those that have above a certain limit of probability of being fraudulent. I already have 37, 39, and some non-fraudulent transactions, sometimes new one. And at the bottom, I see the actual table with the probability of fraud and non-fraud for each of my transactions. Have my email box, which should have been in the inbox, so sorry for that, where I am receiving in real time my alerts for every time fraudulent is positive. The email contains an image that is related to the alert for the specific person, and I press the link. It opens Spotfire on web player, and here going to show it on the web client, which contains the whole context for the transaction. So in this case, we have received an alert for Randy Collins, and when we receive the alert, we receive all the respective context. So we see that he has had transactions in the past with all of these people. Now, if I select, say, Virginia King, by looking at all the databases in the bank, I can see that all they have in common is this same transaction. I choose, say, Ricky Russell, and notice Ricky Russell is also in pink, so we put pink for any customers who have in the past received alerts. So Ricky is already a bit dodgy. And we can see that Randy and Ricky both have the same email and phone number. And David as well with Randy, they both have the same tax ID. Now, if these people may be making fake profiles for doing their transactions, and so therefore we can see that maybe they didn't even bother to do it completely. In the sheet, I have the time series, so I can see all Randy's transactions historically, including the values of his transactions. And on the right-hand side, in more faded color, I have how his peer, the transactions of his peers. So, so if Randy is, say, a cobbler, I'm going to compare his transactions with other cobblers in his neighborhood and see that it's actually quite uncommon to have about $2 million of transactions. So he is a bit unusual in relation to his colleagues. So press, you have the details of the operations that I need to investigate more carefully. For example, this SWIFT originating from this bank ID and in this amount. So that's the show today. Thank you for your attention. Action on the TIBCO.